Okay, in part B it says P0, P1 is this length, so it's the length of this line here basically, and P0, P2 is the length of this line, and it shows that it says show that the length of this times the length of this equals 3. That's the question. Now, these are these points represent the roots of the equation z cubed equals 1. And the roots are 1, omega, and omega squared. Now, omega is this, e to the 2 pi I over n. Now, well, this point, P0, is this. It represents 1. So it's literally just 1, 0, because it's 1 in the real direction and 0 in the imaginary part. So this is 1, 0. So this length is 1 from here to here. In fact, the radius of the circle is 1, which is useful. Now, I could do this quite easily now, guys, because, well, not that easily, but I know that length is 1, and I know that length is 1, and I know this length is 2 pi over 3, because it's essentially, this is 2 pi over 3, this is 2 pi over 3, and then this is 2 pi over 3. So I could just use this length is 1, this length is 1, find x using cosine rule. I could do that. In fact, that is what I'm going to do. But before I do that, let me just write this in, 2 pi over 3. Okay, that's probably the easiest way to do it, because there's actually a lot of different ways you could do this, but that would be my preferred way of doing it, and I hope you understand what I've done there. Before I do it though, I just want to go a little bit further than I need to, just to kind of show you what these points are, because I think it'll help with understanding. So this point is 1, 0. This point is omega. So omega is some complex number. And when it's in, this is Euler form. So the different forms of complex numbers, they all have their benefit, but the actual rectangular form, or the Cartesian form, which is the a plus bi form, this guy's form is useful because I can just, it's like a point. It's like a, b is the point on the Argand diagram. So I'm actually going to turn it from this form into rectangular form. And the way I do it is I say omega is equal to e to the 2 pi I over 3, because n is 3 in this case, which is equal to, first I'm going to change it to polar form, which is cos 2 pi over 3 plus I times sine of 2 pi over 3. Cos of 2 pi over 3, hopefully you know that, guys, it is negative half, and sine of 2 pi over 3 is root 3 over 2. So it's plus I times root 3 over 2. So that's what omega is, which means this point is actually minus a half, comma, root 3 over 2. And this point is actually minus a half, minus root 3 over 2. Now I'm going to show you how to get this one as well, because when you square these, when you get omega squared, what you end up doing is you end up saying, well, this is just e to the 4 pi I over 3, which is cos of 4 pi over 3 plus I times sine of 4 pi over 3. What is cos of 4 pi over 3? Well, it's negative a half. And what is sine of 4 pi over 3? Well, it's minus root 3 over 2. Should you know how to do those? Should you know those ratios as quickly as I know them? It helps. Obviously, you have your calculator. You could just use your calculator, but I actually know them, and I would recommend you knowing them as well. Okay, anyway, this I think is useful to kind of show you what's going on, and you can use these now. Well, you could find this length using Pythagoras' theorem, actually, because this length here is well, it is actually minus 3 over 2. It's root 3. This length here is root 3 because it's root 3 over 2 plus root 3 over 2. And it's actually the same as this length here. So this length is root 3. This length is root 3. So root 3 times root 3 is actually 3. So that's certainly a way to do it. If you're going to go to this much effort, you may as well do it this way, because this way is easy now. That length's root 3. So root 3 times root 3. But I did say I was going to do it the cosine rule way, so let's just do it that way. The cosine rule is x squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times cos of 2 pi over 3, which is 1 plus 1 is 2, minus 2 times cos of 2 pi over 3. We've actually got it here. It's a half. So that is actually equal to a half minus a half. Minus a half times minus 2 is 1. So it's just plus 1, which is 3. So x is equal to root 3. Therefore, P0, P1 equals root 3, and P0, P2 equals root 3. So P0, P1 times P0, P2 equals root 3 times root 3, which is equal to 3. As I said, we could have got it already. Root 3 times root 3 is 3. But there we go. That's part B. Definitely, if you just did this without going to all this trouble, you would get full marks. Similarly, if you did go to all this trouble and just said P1, P2 is root 3, therefore these are root 3, that would also be fine. Okay, done.